Ever wonder how your body bounces back from illness? Fighting off colds, healing that scraped knee. It's amazing.
It is remarkable how our bodies just seem to know how to handle these everyday threats.
Right. But what happens when the enemy is relentless, like cancer or a chronic virus?
That's when things get really complicated.
It's like running a marathon every day. Eventually,
Yeah,
you'd get tired, right?
absolutely. And our immune cells can actually experience something similar.
T-cell exhaustion, right? That's what we're diving into today.
Exactly. We're tackling T-cell exhaustion and exploring how a protein called TIM-3 might hold the key to unlocking a whole new generation of treatments.
So no more fighting the good fight. What's the deal with this TIM-3 character? Is it the one waving the white flag?
Well, TIM-3, or T-cell immunoglobulin and mucin domain containing 3 to be precise, is a bit more complicated than that.
Okay, more complicated how? Lay it on me.
Imagine it as a communication hub on the surface of your immune cells. Normally, it helps keep things running smoothly, making sure your immune system doesn't overreact and attack healthy cells.
That's a good thing, right?
Definitely. But when T cells are constantly bombarded by threats, like in the case of cancer or chronic infections, TIM-3 can start sending out signals that dampen their response.
So it's like telling those exhausted troops to stand down when what you really need is for them to keep fighting.
Exactly. And that's why researchers are so interested in it. By understanding how TIM-3 works, we can start to develop ways to manipulate it, essentially turning off that stand-down signal and allowing those exhausted T cells to get back in the fight.
Okay, so TIM-3 is kind of like a double agent. Helpful in some cases, but potentially a real problem in others.
Exactly. And that's why it's such a promising target for new therapies.
Now that sounds promising. But before we dive into the potential treatments, let's go back to T-cell exhaustion for a second. You mentioned it's like hitting a wall. What are the signs that those T cells are starting to burn out?
Well, for one, they become terrible communicators.
Terrible communicators. What do you mean by that?
You see, our immune system relies on a complex network of signals to function correctly. When T cells detect a threat, they normally send out alerts to other immune cells, like calling for backup.
Makes sense. So what changes when they get exhausted?
When they're exhausted, those signals become weak and muddled, making it harder to mount an effective defense.
So it's like trying to coordinate a counterattack with a walkie-talkie that's full of static. Not exactly ideal in the middle of a battle. What else happens to those worn-out T cells?
They also struggle to multiply.
They do.
Yes. Normally, when your immune system detects a threat, T cells replicate like crazy, creating a massive army to fight off the invaders. But exhausted T cells lose that ability.
Oh, no.
So even if they wanted to fight, their numbers are depleted and reinforcements are limited. Imagine trying to win a war with a shrinking army.
Definitely not a recipe for success.
Mm.
So we've got these exhausted T cells struggling to communicate and running low on reinforcements. Not good. But that's where the research on TIM-3 gets really exciting, right?
It does sound bleak, but there is hope.
Because scientists have found a way to hack the system and potentially reverse this exhaustion.
You could say that. It's like they found a way to release the brakes on the immune system.
Tell us more about these TIM-3 inhibitors and how they work. I'm intrigued.
Well, remember how we talked about TIM-3 sending out those stand-down signals? TIM-3 inhibitors are designed to block those signals, essentially taking TIM-3 out of the equation.
And that's a good thing.
It is. By doing that, they free up those exhausted T cells to wake up, start multiplying, and get back to doing what they do best, fighting off threats.
It's like giving those worn-out troops the second wind. And I imagine this could be a game changer for treating diseases like cancer, which often thrive when the immune system is weak.
Exactly. Cancer is a really tough opponent and often takes advantage of any weakness it can find.
So are these TIM-3 inhibitors proving to be effective? What are researchers seeing?
It's still early days, but the early results are incredibly promising. Clinical trials are showing that TIM-3 inhibitors, especially when combined with existing immunotherapy drugs, can shrink tumors and improve survival rates in several types of cancer.
Several types of cancer, like what? Give us some specifics.
We're talking about melanoma, lung cancer, and colorectal cancer, just to name a few.
That's incredible. We're talking about potentially transforming cancer treatment as we know it. But what about those other conditions we mentioned earlier, like HIV and hepatitis B and C? Could TIM-3 inhibitors also help fight off those chronic viral infections?
Absolutely. That's one of the most exciting aspects of this research. Chronic infections like these are notorious for wearing down the immune system.
Leading to that T-cell exhaustion we've been talking about.
Exactly. TIM-3 inhibitors offer a way to potentially reverse that exhaustion and give the immune system the boost it needs to gain control over these persistent viruses.
So instead of just managing symptoms, we're talking about potentially curing these diseases. That would be revolutionary.
It would indeed. Imagine a world where chronic infections like HIV are no longer a life sentence, but something we can treat and potentially eradicate. TIM-3 inhibitors offer a glimmer of hope for that future.
This is why I love a good deep dive.
Yeah.
You never know what groundbreaking discoveries are just around the corner. But as with any new medical treatment, I'm sure there are challenges and potential downsides to consider. What are some of the hurdles researchers are facing when it comes to TIM-3 inhibitors?
You're right to be cautious. While the potential benefits are enormous, we're still learning about the complexities of the immune system and how to manipulate it safely and effectively.
What sort of things are we talking about?
One concern is the potential for immune overreactions.
So by taking the brakes off the immune system, we risk sending it into overdrive.
Precisely. Remember how TIM-3 helps prevent the immune system from attacking healthy cells? Well, if we completely block its activity, there's a chance the immune system could become overzealous and start attacking healthy tissues. It's like stepping on the gas too hard after releasing the brakes. You might end up losing control.
So yeah, finding that balance is going to be key. Are there other challenges?
Another big one is figuring out who will benefit most from these treatments.
So not everyone will respond to these treatments in the same way.
Exactly. Some people might see incredible result, while others might not see much benefit at all.
And I imagine in some cases, there could even be adverse reactions.
That's right, unfortunately. That's why researchers are working hard to identify biomarkers.
Biomarkers.
Yes! Specific indicators that can help predict how someone might respond to a particular treatment.
It's like trying to find the right key for each lock.
A very good analogy.
If we can personalize these treatments, it can make a world of difference.
What are some of the other questions researchers are trying to answer?
One area that's particularly intriguing is the potential for tumor cells to develop resistance to TIM-3 inhibitors.
Oh, right, like that game of cat and mouse you mentioned earlier.
Exactly.
Yeah.
Researchers are already seeing hints of this resistance in some studies.
That's not good. It's not a reason to panic. Instead, it highlights the importance of continued research and the development of new strategies to stay one step ahead of these crafty cancer cells.
So while we celebrate the early successes of TIM-3 inhibitors, we also acknowledge that the journey is far from over.
It's true. This is where the spirit of scientific inquiry truly shines, constantly pushing boundaries, seeking deeper understanding, and refining our strategies.
So what are some of those strategies? What does the road ahead look like for TIM-3 research?
Well, one promising avenue is exploring combination therapies, hitting those cancer cells with multiple treatments that work in different ways.
So instead of just releasing the brakes with a TIM-3 inhibitor, we're talking about fine-tuning the entire engine of the immune system.
Exactly. We can combine TIM-3 inhibitors with other immunotherapy drugs, each targeting a different checkpoint molecule to create a powerful synergistic effect.
It's like assembling a team of superheroes, each with their own unique powers to take on a common enemy.
I like that analogy. And as we identify more of these checkpoint molecules and unravel their intricate relationships, the possibilities for combination therapies become even more exciting.
It's mind-boggling to think where we might be in just a few years. Will we look back on these early TIM-3 trials like the first Model T compared to a Tesla?
Perhaps. The pace of discovery in immunology is truly remarkable. What seemed like science fiction just a few years ago is rapidly becoming a reality.
It's really quite amazing.
And this is just the tip of the iceberg. There's still so much we don't know about TIM-3 and its interactions with other immune system players.
That's the beauty of scientific exploration. Every answer leads to more questions, propelling us further down the path of discovery.
Exactly. And the insights we gain from studying TIM-3 have implications far beyond just cancer treatment. This research could revolutionize how we approach autoimmune diseases, organ transplantation, and even the aging process itself.
Wow, it's amazing to think about the ripple effect of this one protein. Who knew something called TIM-3 could hold so much potential?
That's the thing about science. It's full of surprises. And it underscores the importance of investing in basic research, exploring those fundamental questions that might seem esoteric at first because you never know where they might lead.
Well said. So for all our listeners out there who are now as fascinated by TIM-3 as we are, what's the takeaway? What should they be paying attention to in the coming months and years?
I'd say keep your eyes peeled for news about clinical trials, especially those exploring combination therapies with TIM-3 inhibitors. And don't be afraid to dive deeper into the research yourself. Curiosity is the engine of scientific progress.
Couldn't agree more. There's so many resources available online, from scientific journals to reputable science news outlets. If you hear a term you don't understand, don't be shy about looking it up. You never know what fascinating rabbit holes you might go down.
Well said. And who knows, maybe one of our listeners will be inspired to join the ranks of scientists working to unlock the full potential of TIM-3 and revolutionize medicine as we know it.
Now, wouldn't that be something? And on that note, we'll wrap up this deep dive into the world of TIM-3. Thanks for joining us on this incredible journey of scientific discovery.
It's been my pleasure. Until next time, keep those minds curious and those questions coming.